Hello friends, today we have the question of trigonometry and it is proved that. So let's read out the question first. We have question cos square beta minus sin square alpha upon sin alpha into cos alpha plus sin beta into cos beta equals to cot alpha plus beta. So in this question we are going to solve it from right hand side. Okay, so I am solving it by taking RHS. So solution, taking RHS. So in RHS we have cot alpha plus beta. Okay, so now let's solve it. Cot alpha plus beta, we have the formula in the term of addition of cot alpha plus beta equals to cot alpha cot beta minus 1 upon cot alpha plus cot beta. So this is the formula that you are familiar with. Okay, so the cot alpha plus beta equals to cot alpha into cot beta minus 1 upon cot alpha plus cot beta. So now let's solve it. What we have the formula of cot alpha, cos alpha upon sin alpha. So we are going to use the formula of cos alpha upon sin alpha. Similarly, cot beta is cos beta upon sin beta. Okay, so minus 1, we are just reducing in the form of cos upon sin. Okay, this is you are familiar with this. We are reducing our cot term in the form of cos and sin. Okay, so same thing we will do in numerator also and denominator also. Now let's check. Cot alpha is cos alpha upon sin alpha. Similarly, cot beta is our cos beta upon sin beta. Okay, so we have not done anything complex till here. Now let's solve it in numerator first and then denominator. Okay, so in numerator we are going to solve. Simply just take LCM. Cos alpha upon cos beta minus sin alpha dot sin beta, and in denominator it will be this sin alpha into sin beta. This is just a solution of fraction. Okay, nothing more complex here. I have just solved the fraction. Similarly in the denominator also same way we will solve. Let's keep this equal to sign in the middle. So in denominator also we can do cos alpha into sin beta, cos alpha dot sin beta plus cos beta dot sin alpha. Nothing complex here, it is just a solution of fraction by taking LCM. Okay, so that is not a great deal. Sin beta, so here both the denominator will be cancelled by reciprocal. So I have done it in short way, no need to expand it like kids. Okay, so okay, cos alpha dot cos beta minus sin alpha dot sin beta upon this sin alpha sin beta, and sin alpha sin beta will be cancelled because of reciprocal. Okay, so that you don't need to show here by expanding it, you can just simply cancel it here. Okay, so there cos alpha dot sin beta plus cos beta dot sin alpha. So okay, now the main thing starts from here. What we are going to do here is multiply and divide with the this upper term. What we have here in the numerator, cos alpha into cos beta minus sin alpha into sin beta. So we are going to multiply and divide with cos alpha dot cos beta plus sin alpha dot sin beta. Okay, so I am going to show you here. We are just going to multiply and divide with same term. Okay, so here also you can do, or here also you can do, not a great deal. Okay, so I will just change the color to show you. I am doing it here. I am multiplying and dividing with the same term. So what we will do, we will multiply with cos alpha, just take numerator and change the sign. Okay, cos alpha cos beta plus sin alpha sin beta. I have just changed the sign of in between the terms. Okay, so what will this effect, it will make our formula easy. Cos alpha cos beta plus sin alpha sine beta. We can multiply and divide with the same numbers or same terms in the our mathematics. Okay, so this is what I have done here. This will make our expression more simpler, or it will be easier to convert it in the formula. So now let's solve. Now what we are going to do here is multiply this both terms. Okay, so it is like now algebra. Multiply with this both term, multiply numerator and denominator. Okay, so now let's multiplying cos alpha cos beta with this whole term once again, then this with this. Okay, so we are going to show it like, let's change the color. Cos alpha cos beta, multiplying this whole term, cos alpha dot cos beta plus sin alpha dot sin beta. Similarly multiply with this minus sin alpha dot sin beta cos alpha dot cos beta plus sin alpha sin beta. If you want, you can skip this step and just move to solution. Okay, no need to show it like this, but I am showing it here to make you understand. Okay, so in denominator also dot sin beta, multiply all this whole cos alpha cos beta plus sin alpha sin beta. Similarly multiply with now this term plus cos beta dot sin alpha, and it will be this whole term cos alpha cos beta plus sin alpha dot sin beta. So this will be, now it is simpler, so just multiply it. It will it looks a bit lengthy, but it is simpler. Okay, just multiply it. What we will get in the numerator here, cos square alpha cos square beta, and this will be like plus sin alpha sin beta cos alpha cos beta. Similarly minus sin a sin b, so it will be sin a dot sin b cos alpha cos beta. So and now multiplying with this term, it is minus sin square alpha square beta. Now give the fraction. Similarly in denominator also we will just expand it, cos square alpha sin beta cos beta plus, now multiply this with this, so it, what are the similar term? Okay, sin square beta cos alpha sin alpha. Similarly plus multiply this whole term, so it will be our cos square beta sin alpha cos alpha plus this multiply with this term. Okay, so it will be like sin square alpha and sin beta cos beta. Now just wait for a few seconds. This term and this term both are similar but with different signs, so this gonna be cancel. Okay, so this is this will, in numerator we will get more simpler form. Okay, so in numerator we will be left with, okay, so this and this is our cancel. So what we will be left with, cos square alpha cos square beta minus sin square alpha sin square beta. Okay, upon in denominator what we are going to do, okay, so wait for a few seconds, let me explain you. Look, this term, in this term and in this term, what we have common? Sin beta and cos beta. So we will take this common, and remaining it will be sin square alpha plus cos square alpha. Similarly, in this term and in this term we will take common of what? Sin alpha and cos alpha, because both are we have common terms like sin alpha and cos alpha. So what we will get? Let's see. So in denominator, I have underlined with the green color, so check it here in the term underlined with green color. So in that term we are taking a common of sin beta cos beta bracket what we are left with? Cos square alpha plus sin square alpha. We got the smaller term, isn't it? Because we have the formula of sin square alpha plus cos square alpha equals to 1. Similarly, look at the term with the red underline. So here what we are going to get after taking common of sin alpha and cos alpha. So here we are taking common of sin alpha cos alpha in the brand. We are left with sin square beta plus cos square beta. Okay, so now let's check it. We will get this term will be our what? 1, isn't it? We have the formula sin square theta plus cos square theta equal to 1. So this term will be 1 1. And now let's check in the left hand side. We have got the denominator, isn't it? Sin alpha and cos alpha, sin beta and cos beta. If we are about to get this. Okay, so sin alpha cos alpha and sin beta and cos beta, we have got the denominator. And now let's check in the numerator. Did we get left hand side? Cos square beta minus sin square alpha. So we have to work out more here in the denominator almost we reached. Okay, so we reached the denominator. What we want to get, we got that. But in numerator we have to solve a bit more. Okay, so if you don't want to do this much, we have the direct formula also. So I'm not going to explain that to you here. Okay, so just I'm expanding it, making it a bit lengthy, because it is this types of question carry more weightage. Okay, so just solve by this process, that will be better. So in this question I am going to get the numerator. Okay, so in numerator what we are going to do, look, cos square alpha is there, isn't it? So what we can do is convert it into the term of sin. So cos square alpha is equals to 1 minus sin square alpha. So in terms of cos square alpha, what we can write? 1 minus sin square alpha, and the remaining will be cos square beta. And similarly in right hand side we will convert the term sin square beta into 1 minus cos square alpha, because in numerator what we want to get sin square alpha, isn't it? So we want to get sin square alpha. So just change the term with the beta, just leave it sin square alpha as it is, and change the sin square beta in the term of cos 1 minus cos square beta. Now give the big underline. Okay, now in denominator what we are going to write? Sin beta cos beta. No need to write 1 because it is already 1. Multiply with 1, so 1. Sin alpha cos alpha, sin alpha cos alpha. Now in numerator we are just going to expand it. Okay, so just expand, multiply and open the bracket. So cos square beta and multiply with this, so it will be like cos square beta minus sin square alpha cos square beta. Similarly minus sin square alpha plus sin square alpha cos square beta. So now it has become more easier. Look, give the fraction first. So I'm going to show you. Look. Okay, write the denominator by arranging. So sin alpha, I'm writing it in this side because we have arranged. I'm going to arrange it. It will be more easier. It will reduce our steps. Sin beta cos beta. Isn't it that we want denominator in this? Because in denominator we just want sin alpha cos alpha plus sin beta cos beta. Okay, so in denominator we got, and now in numerator, look here, this term and this term we are going to cancel it because these terms are same but we have different sign. So we also got the numerator. So finally we are about to get left hand side cos square beta minus sin square alpha upon sin alpha cos alpha plus sin beta cos beta. We got equals to our LHS. Hence proved.